Okay, in our lesson today, we're going to look at how to solve equations with variables on both sides. Our essential question is, what are the steps to solving equations with variables on both sides? Later on, we're going to learn a funny little saying to help us remember the steps. But until we get to that point, I want you to think about some things. There definitely is not just one way to approach this problem. But I'm going to give you the way that I find is the easiest and that I think causes the least confusion and less errors. So when we have an equation with variables on both sides, you're going to see that none of these equations here need to be actually simplified. So we're not going to add that step into our next lesson. So what we would do first in this case is we're going to move our variables to the same side. Move our variables to the same side. You don't have to do this first, but I find this causes less errors if we go ahead and take care of that. After we move our variables to the same side, we're basically going to be looking at a two-step equation. So the next thing we were going to do is add or subtract our constant term. Add or subtract the constant term. And then our last step, hopefully we know, is always to either multiply or divide, depending on what number we have with our variable. Okay, so let's look at this first example. When we decide to move our variables to the same side, it doesn't matter if we move them to the left or we move them to the right. It's really your preference. I know a lot of people like their variable to be on the left side, but it doesn't matter. If you need to, draw a line down through the equal sign to keep your sides separated. So if I'm going to move this 2k, move my variables to the same side, and this is what I want to move, I'm going to move it by adding or subtracting. And maybe we should add that to our steps. When we move our variables to the same side, we do this by adding or subtracting. Okay, we've already been doing a lot of this, so it shouldn't be uncomfortable. So since it's a positive 2k, I'm going to subtract 2k. Okay. That leaves me with 4k minus 3 equals 13. And now this should look like a real easy equation to you. Now we're going to add or subtract the constant. Remember, negative 3 is called a constant because it doesn't have a variable with it. So add 3. That leaves me 4k equals 16. And then our last step, multiply or divide, and the inverse operation would be to divide. And so our solution is k equals 4. Now the check part, we haven't done a lot of this, but remember you can check your solution by plugging it back in. So everywhere we see a k, we're going to plug in a 4, and we're going to check to see that that really does come out equal, that it really does solve the equation. So this would be 24 minus 3, which is 21. And this would be 8 plus 13, which is also 21. So yes, we're good. That is the solution to our equation. Okay, let's look at the next example. We need to move our variables to the same side. A lot of times I'll just pick whichever one is smaller, or sometimes if it's negative and it lets me add, then I'll add. But in this case, I'm going to choose to move the 3m. So I'm going to say minus 3m because that makes a zero pair. Minus 3m. 6m plus 7 equals negative 5. Make sure you write the sign that goes with it. And now we just add or subtract our constant. This is a positive 7, so minus 7. Be really careful with your integer rules here. This is going to be negative 12. And then we simply divide by 6, and we get m equals negative 2. And so again, to check our solution, we can plug in negative 2 everywhere we see an m and see if it really does make our equation true. This would be negative 18 plus 7, which is negative 11. This would be negative 6 minus 5, which is also negative 11. So we're good again. Okay, the next problem. I know you are all hyperventilating as soon as you saw all these fractions. But remember, don't panic. Okay? First of all, I do want you to know that this would be an example where if you wanted to clear out your fractions, you could do that. I'm going to go ahead and work through it, leaving the fractions because you're going to see that they quickly go away. I'm going to still choose to move my variables to the right because this is a negative 3/5 n. And so that's really easy to say plus 3/5 n. And what you're going to see here is 2/5 plus 3/5 is 5/5. Well, what is 5/5? 5/5 is 1 n, or simply n. So we didn't really need to clear out our fractions because as soon as we moved our variables to the same side, the fraction went away. And now this is really easy. All we have to do is add 9, and we actually don't have another step. That is our last step. We could again check that by plugging it in. It was going to be a little bit messy, so I'm not going to take the time in the video to plug that back in and check it, but you know that you could. Okay, the last problem. I'm going to take and move my variables to the right this time. So I have a negative 2p, and so the opposite is going to be to add 2p. Okay, remember we're creating zero pairs, that's why we're doing the inverse operation. And we get 8 equals 6p minus 10. Then I would add 10. Remember, once we get our variables on the same side, we want to concentrate on the side with the variable and concentrate on moving and getting rid of the numbers there. So add 10. That gives me 18 equals 6p. And then our last step is to divide by 6. And so p equals 3. For your entrance ticket, I want you to try to solve the following equation. And I also want you to remember to do your video check, your CFU, before you log out of Canvas. If you're not in Canvas, you need to go get into Canvas. Okay, so negative 3r plus 10 equals 15r minus 8. Solve that and be ready to post it on the board tomorrow.